Hello everyone. Today I'm going to show you a quick tutorial on how to find the voltage and the current at each component on this circuit. Also, we'll show you how to change the circuit name and to add a text to the circuit like a title or something like that, something explanatory. So this circuit here is already built in. So this is basically a series parallel circuit that cannot be solved immediately. So we need our measurement devices. So let's say for now we want to measure the current that leaves V1. So here we'll go to the measurement tools, current, and we'll put it here. As I mentioned earlier, that the current will not be shown unless I run the simulation button. So if I want to run the simulation, just run, and there you go. The value of the current will be given like more or less 279.21 milliampere. And by the way, since this one is a simulation, the result will be accurate. So we do not truncate, let's say, any values. And by the way, the system here is showing me a warning that I did not add the ground, so I have to add it. So let's stop the simulation, hide the window. So let me add the ground here. And usually the ground is right next to the supply voltage, the negative terminal of the supply voltage. So again, let's run it, and we have the same exact value. All right, so this is it. So if you are asked about the current that passes through R1, here is the value R1. So this is how you find the value. So if you want to find the current that passes through each branch or each resistor in this circuit, you do this one. So current, so this is the first one, copy it. This is the other current that passes R2. Copy it. So this is R3 here. Copy it. R4 here. R5. 6. And 7. I don't think we need to find the current that passes R8 because basically it's the same. It is the same current that passes R7, but we will put it just for sake. Okay, so this, once you have the whole configuration ready, just click run, and there you go. You'll find the current at each component in the circuit. And yeah, let's ignore the negative signs here, basically because I'm assuming that the current is going from left to right. If you see this small arrow here, but in fact the current is going the other way. And actually you can compare the values between R7 and R8. So here's negative 80, here's positive 80. So it's the same exact magnitude, but the current is assumed to be going in this way. So this is how you find the current at each component in the circuit. Now let's try to find the voltage. So let me remove each component here. Now the voltage is a bit different. You have to show the reference for each voltage. So usually to measure the voltage, so click on voltage. Now once you click here, it'll give you the option of this V minus. V minus is your reference. So there you go. You put V minus and that's it. This is to find the voltage across R1. Now similarly, you repeat the same step for R2 and the reference at the other terminal. Then I'm going to do it for just 3 resistors. So for R5, I'm going to do it this way. The reference will be at the other side here. Now to find the value, and there you go. So this is how you find the voltage drop across each resistor. This is just a part of the lab. This is probably part 3 of the lab. At the beginning, you have a series circuit. That's part 1. Part 2 is parallel circuit. Part 3 is a series parallel circuit. The circuit I'm providing you in the document, which I will show in a few minutes, is a bit different or easier than this one. Okay, to change the title of this circuit, all you need to do is here. So you just say part 3 series parallel circuit and fix any typos. There we go. So this the title of the circuit, it's let's say is changed. Now if you want to add the text, and here I'm going to tell you what you need to add. So Let me just type here text in the search. There you go, text annotation. And I believe you can find it somewhere here. Yeah, there you go, at the measurements, text annotation. So once you click this one, you just create a box and you can double click and you change the text. What you need to add here from now on every circuit you create, type your name and ID. So ALKH890 and ID, you just put your A 1, 2, 3, 4, 5, 6. And that's it. Once you are done, click anywhere and there you go. That's the text here. So from now on, in every circuit you create, have this text annotation to show your name and ID. And by the way, the circuit is not saved yet. So to save it, to have it at your, let's say, in your profile online, just click save. So you have to make it in public. Private is for premium accounts. We are using the free, so keep it private. And then the description is optional. You can just say this is for lab 7, lab 6, whatever the lab number is, to discuss or to experiment some circuit measurements. And that's it. Now, once the saving is done, if you look on top here, the link here has changed. It's a bit long one. It doesn't matter. All you need to do is to copy this part here. Do not copy the open thing. This open, you don't need to copy it. So you just copy this whole URL and add it to your report. Okay, speaking of the report, so let me open my Word file to discuss what you need to perform. And actually the report is already in the OneDrive folder. So I'm just gonna open it. So share my Word file. Oh, sorry, I did my Outlook, my bad. Okay, so let's share again. And this is the Word file. All right, so we have this, the circuit. So I prefer if each one can add the CRN to the title, and you write your name and ID. Okay, so for a refresh, you just refer to experiments 2 and 3 for the theoretical and practical aspects of series parallel circuits. Now, the first part, series circuit, you just need to design or add the circuit. Do not forget to add the ground, even though the ground is not shown for the simulation to be accurate. You need to add the ground. So you have a 3 resistors series circuit, and what you need to measure is, well, first calculate theoretically the total resistance. So there you go. You have to theoretically add the resistors to get the value R total. Now, using the measurement tools on the website, measure V1, V2, V3, and I total. So V1 is the voltage across R1, voltage across R3, and so on. Now, I total is the current that's leaving the source, like this point here. Okay, so once you've done the measurements, try to verify if V1 and V2 and V3, they equal V total. V total here in this case is my source, which is 50 volts. So just verify it. It's just simple addition. If they're not equal, then you have something wrong in your, let's say, measurements. Or probably the circuit structure, probably you put a wrong value for a resistor. And yeah, definitely in every requirement here, you have to show the mathematical formula and you substitute their corresponding values. Now also verify that VT over IT equals R total. So VT is given, is the power supply in the circuit. IT is the one you measured here. So just do the division, VT over IT, and you should get R total is the one that you, let's say, calculated here. They should be, and they should be exactly the same. Again, in simulation, a point I want to remind you that there is no room of errors. If there is an error, that could be something wrong with the circuit, let's say, structure or building. Simulation environment, usually you will get ideal situation where there There is no room for errors. All right, so this is the series circuits part. Now for the parallel circuits, you have this circuit, 3 resistors. Similarly here, you have to calculate the total resistance. So I'm giving you this formula, just substitute the values. Do not put just the final answer. Substitute the values and show me your, let's say, show me your final answer, the result. Now again, using the measurement tools. Now this one is a parallel circuit, so all voltages will be the same. So calculate the, I1, which is the current that passes R1, I2, and I3. Now I total, also you need to measure it. You don't have to calculate it. So measure it using the measurement device and the website. So you perform the measurements in all cases. Now verify if I1, I2, and I3, they are equal to I total. So just simple algebraic formula and just plug in the values and the result should be there. And again, verify that VT over IT equals R total is the one that we calculated in step number 2. So that's for the parallel part. And the requirements are similar. Now here is the series parallel combination. Now in this one, we have like a bit larger values, different from the one I had in the website. So R total, you have to apply the formulas like what we did in the class. Those resistors and series, their combination is in parallel with R2, then the whole combination will be in series. So you just do your math and you have to show the detailed steps here. It's not a direct formula that you just substitute the values and you get the output. All right, now using the measurement tools on the website, now this one is going to be a bit complicated. So you have to find the voltage drop across each resistor. Then you have to find the current that passes across each resistor. Now in this one here, once you, let's say, because the circuit now you'll have about 12 measurement devices, 6 for voltage and 6 for current. What I suggest, do one for the voltages, take a screenshot, attach it. Current, do one with the 6 current measurements and take a screenshot. So for this part, you need to take 2 screenshots. Now for the power here, there is no way you can measure the power. There's no device to do that. So you just need to calculate it by multiplying voltage by current. So that's the power formula, I times V. So this one here is not measured. This one is to be calculated. All right, now again, similarly, VT over IT. IT again is the current that's leaving the source. So even though it's not mentioned here that there is IT, but this one is the current that's leaving the source, which is similar to R1, the current that passed through R1. All right, so verify if it equals R total that you did in step number 2. And last thing, you have to do the conclusions, summarize this experiment. And here you just need to discuss, do a comparison between simulation and practical. And you have to mention at least 2 advantages. So in simulations, what are the advantages of simulation? You just mentioned 2 here. So you have 2 bullets. Now the practical, it has also advantages. What are they? And even though simulation gives you perfectly correct results, what are the disadvantages? This is kind of an open answer kind of question. I suggest you look up into the internet and you can find many resources on that one. And that's it. That's pretty much it for the lab. It might look long, but if you follow the steps one by one, the lab should be easy. And by the way, for each circuit here, you need a different URL. Those all 3 designs should be there in your, let's say in your profile. So let's say once you created the series part, save it, create a new project, do the parallel part, save it, do a new project, 3rd part, and save it. So in this one, you have to make 3 designs, 3 URLs you have to attach in your submission. And that's it for the lab. And as usual, if you have any questions or queries, send me an email or write me on Telegram. And inshallah, I'll be as responsive as possible. All right, so that's it. So I'm gonna stop recording.